Hi everyone, today we're going to look at Boyle's law. So, Boyle's law states that when the volume in a container of air decreases, the pressure of that air inside that container increases. So, this relies on the property that any air takes up the volume of the container in which it is. Therefore, the volume of a gas is the volume of the container. So, to demonstrate that, we have this lovely apparatus here. So, in this apparatus, we have this syringe, kind of a structure where I can decrease and increase the volume. Here there are some centimeter markings, so we can see that the gas starts with 65 centimeter cubed of air. This is a temperature gauge, and this has a sensor placed inside the cylinder, so we don't have to really do much about the cylinder, the temperature. So for this law to hold true, the volume of the gas, the mass of the gas, not the volume, the mass of the gas and the temperature must be held constant. So to keep that mass of the gas constant, we've got this valve here which I can close now. And by doing so, I have restricted the volume of gas, the mass of the gas into this volume. So whatever the volume of this syringe would be, will be the volume of the gas. Now, this is a pressure gauge. So in the red outline, you can see the pressure in atmospheres, and the outside part is, I think, in PSI, which is pounds per square inch. So using this apparatus, we can verify, or we can rather show, the Boyle's law. So let's get into the experiment. Okay, so now I've opened the valve just to show the control. So with the valve open, if I change the volume, there is no change in pressure, because the mass of gas can escape from here. And also there is no change in the temperature, which is 26.3 degrees Celsius at this moment. So in the ideal gas laws, in calculations, we always use Kelvin, but conventionally everything's in Celsius. So even this one is in Celsius, but for calculation purposes, we would ideally use the Kelvin scale. So now let's close this. So the temperature is 26.3. It should not increase a lot for Boyle's law, and since the volume of gas which we're changing is not a lot, the heating effect of that pressure should not be immense. But this is just to monitor this. So from 65, I'm going to decrease the volume to 55 before I stop and explain. So at 55, you can see that the pressure has increased from 1 atmosphere to 1.2 atmospheres. So let's keep decreasing the pressure, the volume, and now the pressure has increased to 1.4 atmospheres. The temperature is constant. Now I'm going to go down and decrease till 30 centimeter cubed of air. So it's the same it's the same mass of air compressed into that volume. And if I decrease it to say 30, just give me a minute. It gets harder as you go down because the pressure keeps increasing, and it therefore resists this piston. So now I've got about 2.1 atmospheres of pressure in that small volume of gas, and the volume of that gas has actually become less than half of the original volume we started with. So let's keep decreasing it to 25 centimeter cubed. That's about 2.6 atmospheres, and going down to 20 centimeter cubes, which is, I think, the lowest we can. No, I can go beyond 20 centimeter cubes in this apparatus. So now this goes to about 3.25 atmospheres of pressure. The temperature, as you can see, has risen by 0.2 degrees Celsius, and that is because of that higher pressure. So there is another law, the Charles's law, which dictates the relationship between pressure and temperature. So when we follow that, the temperature should have risen, and because we were assuming it to be controlled, there is a little variation. This is not the true prediction of Boyle's law, but within the margin of error, it is correct. So now I'm going to open the valve, and you can see the pressure jumps back to the original 1 atmospheres of pressure. So I'm going to close it back now, and we're going to go reverse. So now we're going to increase the volume and watch the pressure decrease. So right now it's at 1 atmospheres pressure, and I'm going to keep decreasing the pressure. So as you can see, as the piston moves up, the pressure keeps falling. Now it is at half the pressure of the atmosphere. Now if we keep going down, keep moving the piston up, the pressure keeps going down, and at 65 I'm gonna stop. So again, like going down or increasing the pressure rather, the piston gets a little hard to pull up at the end because there is excess, because of the low pressure built inside, which is pulling on the piston to decrease the volume. And now the pressure is about 0.4 or rather 35 atmospheres of pressure. And this was the Boyle's law. Thanks for watching.